All right. Okay, so let's now move on to this particular example. So in this case, well, ideally this can actually become an application which you can tie in with a GPS, but in fact due to lack of time we have not been able to do that. But anyway, let's have a look at the application itself. So the application is going to be pretty simple. We have a two-dimensional coordinate system, and we have two random points inside the coordinate system. So one of these points I call as x1 and one of these points I call as p1, the other I call it as p2. So what we are going to try and do is use the standard distance formula to calculate the distance between these 2 points. Now it is obvious that if we can actually tie this into the GPS, we could actually have one stationary point and one moving point. So you could build this application, put it on the phone, put it in your pocket, and then travel, and you can expect to actually have a real-time update of the shortest distance between you and the target point. All right, so now let's move on to actually let's get down to developing this particular application and having a look at it. Again, in this case, just to keep it simple, we are only going to have, again, just one single screen, that is one activity. All right, and it is obvious that part of this project will contain code in Java and part of it will be in C. All right, so what are the steps we are going to follow? We are going to create a new Android project, and in fact that is pretty much the same as in the case of Java. You remember the screenshots, right? So it's going to be more or less on the same line. So you create a new Android project, then you specify what is the build target, I mean which version of Android it is, 2.2, 2.3, 4.0. You specify a package name for your project, and you finally specify a project name, and the Android project is created automatically in Eclipse. All right, so once that is done, in this case what we are going to do is we are going to again go back to the main screen, the layout, and we are going to quickly build it, and then we are going to link it as usual with the backend Java code. Remember that every activity has two things inside. There is code and there is the layout, right? So once we build the layout, we are going to go back to the Java code, then we are going to link these two things up, and finally we are going to execute the application. So that is the basic idea. All right, so quick look at the Java project structure in case we are talking of, obviously in this case we are talking of a native application, right? So as I mentioned, you can clearly distinguish between source code that is in Java and source code that is in a different programming language like C or C++. All right, so quick look at the structure. So in this case, as usual, we have a src folder which contains the Java source files. Then we have the usual Android libraries. So in this case, it is 2.2. Then here is a quick look at the bin folder. In fact, it contains, as usual, the APK file. Now remember that inside the APK file, in this case, we have two different kinds of code which have been built from two different programming languages, that is Java and C. Okay, then here is the difference compared to the previous Java project, and that is a subfolder with the specific name JNI in lowercase. Now, for people who are already familiar with this is the Java native interface. All right. So the point is, inside the JNI folder, there are two specific. Well, there is at least one specific file that must be available in case you want the project to work correctly. Okay, and that file has this specific name. It's called android.mk. There are some settings inside this particular file, and of course, there is in fact the C file itself, which contains part of this the project's code. Right, so we have got the source code in Java, we have got the source code in C. Finally, ahead we look at one very important step, and that is using a tool called as NDK build. Now this NDK build tool is part of the Android NDK. Remember the checklist? I had mentioned that when you're building a Java native application, you need to make sure that you have installed the Android NDK. Okay, so when you're building Java applications, you need to have just the SDK installed. But when you are building native applications, you need to have not just the SDK but also the NDK installed. So one of the tools inside the NDK is something called as the NDK build. Okay, so when you use this NDK build, when you specify this particular project as the input to the NDK build tool, it is going to generate what are called as .so files. In fact, these are, if you remember one of the diagrams which I had described a few minutes ago, it is in fact the dynamic link library, which is in fact the which has to be linked with the application. All right. So now, so what are the steps that we are going to have here? especially as far as the C code is concerned. Okay, we have already seen what are the steps involved as far as Java, the Java part of the application is concerned. So in this case, you will need to have, as I mentioned, a J and I folder inside the project structure, and make sure you have the android.mk file inside it, and of course the source code which you are going to build in C. Alright, then don't forget to invoke the ndk build command. So once you do this, and you should also do it from the project folder. Okay, so anyway, we'll have a quick look at where you can actually find the ndk build command. Okay, and then the ndk build is going to generate the libraries which will be linked during runtime to the Java application. Alright, so quick look at the distance calculator program, but before that, let's have a quick look at the Android ndk. So just give me a moment. Alright, so okay, so in this case on my laptop here, what I've done is I have installed, sorry, it's yeah, it's here. Alright, so in this case what I've done is, this is the folder. Okay, so okay, sorry, I think it's not on this machine. All right, no problem. So anyway, the point is that we have the Android NDK, and the Android NDK is in fact, I mean, you can download it from the Android developers website. Yeah. So okay, anyway, so let's now move on and try to run this particular application. Okay. So first step, we're going to run this as usual on the emulator. So here is the calculator application. I'm going to close that, and let's now start the distance application, right? Okay. So let's just give it a moment. Okay, I think there might be a problem with Eclipse. All right, it's not an issue. Okay, so tell you what we can do is, we already have this application installed on the device. So let's have a quick look at that. So yeah, so all right, so let's look at the application. Okay, so if you observe, we have a distance icon here down below. So that is the distance calculator application. Now let's try to run that. So once we run this, this is how the screen looks like. Okay, so the first two input fields are the x and y coordinates of the point P1 inside the two-dimensional coordinate system, and then the point P2. So yeah, so let's try to fill in the values for P1 and P2. Okay, so let me say I want 10, 10 for x and y for P1, and let's put in maybe 20 and 30 for P2. Okay, now once I'm done with this, so let me hit the calculate button, sorry, the calculate distance button, and there it is. Okay, so this, sorry, I think we'll have to rotate the screen. Okay, just a moment. Yeah, so let's wait just a moment. Okay, so sorry. Okay, so here is the screen. Alright, so when I hit the, there it is, there is the distance. Okay, so this is pretty straightforward. I mean, it's the standard distance formula. It's not rocket science. This is something pretty simple. Alright, so now let's have a look at the project code. Now that we have already seen this application deployed onto the device, so let's go back and look at the source code for the project, give it a quick run through and try to understand how it is built. Alright, so let me start up Eclipse again. Okay, so there is Eclipse. So here is the distance project. Let me open up that. So now, as usual, inside the res subfolder of this project, we have the. Sorry, is there a problem with the audio? Okay, I hope things are fine. All right, so let's continue. So in the res folder, we have the layout subfolder, in which we have the screen for this particular application. As usual, it's just one screen. So I mean, we are trying to keep things simple here. All right. So just give it a moment, let the application open up. All right, so that's the screen which we have just seen before this. So let me zoom in. There it is. This is what we have seen on the phone, right? Okay, so and what is obvious is that this screen, even though this is how it looks visually, has a XML representation in the background. I'm sure most of you have already guessed this by now. So now let's go back into the Java code. Okay, this is the Java code corresponding to this particular activity. Okay, so as usual, what we are going to do is obtain references to all these text fields. Remember, we have got 4 input fields here, 4 input fields in which you can have 4 different values. So what we are going to try and do inside the Java code is we have a method called get input references. So inside the get input references, all we do is obtain references to these 4 fields. Okay, now once that is done, as usual, we are going to register a listener for the button, and so that we know that when the button is clicked, we know that the button has been clicked. All right, so once the button is clicked, what we do here is we call the get input values method, and you can guess what it does already. So what it does is it's going to extract the values for all the 4 text fields, and it is going to convert them into double. Okay, it's going to convert them into double values. All right, then what we do after that is we call a function that's called as calculate distance, and we simply pass it all these 4 parameters. Okay, and of course you can imagine that inside the calculate distance method we have the standard distance formula being applied. So now the surprising part is this line here. You see this? This is the this is not in fact the definition of the function itself. It's in fact a declaration, and you can see the word native here. What that means is this particular function is not written in Java. It is in fact written either in C or C++. Okay, so now let's have a look at the C code itself. Now, as I mentioned, the C code is found inside the JNI subfolder of this particular project. So let's double click on that. Sorry, just a moment. Yeah, okay, so let's open up this inside. Okay, here it is. It's pretty simple. So this is good old C code. So as usual, we have got a bunch of hash includes, and one of the most important hash includes is the jni.h. All right. Okay. So now, if you observe the name of the function here, it is calculate distance. Okay. So in this case, there is a certain naming convention that you will have to follow, and that naming convention goes like this. Okay. First we have Java, and then com sanasi in this case. So which is in fact the package name, if you observe here, of the Java code. Right, then we have the distance activity. In fact, this is the name of the Java class. So I hope the naming convention is so far clear. Then finally, we have the calculate distance. In fact, this is the name of the Java method. So it is pretty straightforward. And of course, we have so many arguments to this particular C function, of which the first 2 arguments are mandatory, and these are expected anyway. After this, we have a bunch of arguments that are very specific to this particular case. So if you can observe back in the Java code, we have got 4 different parameters that we are passing to the C function, and of course those 4 parameters are received here. In this case, we call them as double. I mean, the Java data type is called as double, but in the case of the C code, it's called J double. Okay. So, and of course, this is pretty simple. You can see all we have done is find out the difference of the X values and the Y values. Then we have just calculated the square root, and we are just returning the value in the form of a double. So it's pretty straightforward. Okay. So now, yeah. So this is the application. So this we have observed the code written in Java, and we have also observed the code that is written in C. Okay. One final thing that I would like to make sure that you have noticed, and that is these 3 lines of code here. That is in fact, what we are trying to do is, remember I was talking about the C code getting converted into a dynamic link library and then getting linked into the Java application during runtime. So that is thanks to this particular line. So you can see it is called a system.load library, and then it is the C file that we have built here. So that gets linked into the Java code. Okay. All right. So I think that is the end of the second trail. Now let's move on to the final trail, which is going to be flex. Okay, so let's just move on. Okay, so this is the third trail. In this case, you will need to have the Flex Builder. We are not going to use Eclipse for this. Obviously, we are going to use Flex Builder. Interestingly, Flex Builder is actually a custom built version of Eclipse itself. So in a way, we are deep down, we are still making use of the Eclipse IDE itself. Okay, so let's move on. So what are we going to do again? As usual, we are going to build screens. You can build a screen using drag and drop as usual, or you can also, if you're good at writing XML code, you can also start writing code in XML. All right, so as usual, standard widgets are provided in Flex, and if you're good at XML code, as I mentioned, you can directly start coding in XML. Okay, so the point is, Adobe has a very custom version of XML for this particular purpose. I mean, for building graphical interfaces in Flex. So that is called as MXML. Okay, so you can use MXML to visually represent the screen. So it's more or less on the same lines as the layout that we have seen for the Java project. Okay, and of course, the programming is done in a language that is called as ActionScript. Okay, all right, so let's move on to the next slide. So what is the strategy that, I mean, what is the project about? What is the strategy that we are going to take to build this particular project? So what we are going to do is we are going to build a simple Flex application that will enable the user to take photos from a mobile phone which has a front and back facing camera. So in this case, I mean, it's pretty specific. So you need to have a mobile phone that has both a front and back facing camera. So if you want to run this particular project. All right, so as usual, we are going to try and keep the example simple. So we'll just have one screen, and in that screen we are just going to have a live preview of the front camera or the back camera, depending on whatever the case may be. And so yeah, so that is the idea. And well, I mean, the application finally what it does is it's going to have a button. When you click on the button, the photo will get saved into the micro SD card which is installed on the phone. Okay, so that is the strategy for this particular project. All right, so now let's have a quick look at what we're going to try and do here. So what we're going to try and do is we are going to set up a new Flex mobile project in Flex Builder. Then we are going to, as usual, build the layout, and then we are going to write the corresponding ActionScript code corresponding to that particular layout. So inside the ActionScript code, what is the set of things that we are going to do? We are going to set up what are called as the camera and video objects. Then we are going to write a bit of code that is going to toggle between the front and back camera when the user is going to click on the toggle button, which you'll see a bit ahead. And of course, then we are going to convert, once the user clicks on the button, we are going to convert this raw image into JPEG format, and finally we'll try to save it into the micro SD card. Okay, so this is the set of steps that we are going to follow for this particular project. All right, so quick look at how the screen looks like. So you click on File, I mean, you start up the Flex Builder application, then you click on File, New, Flex Mobile Project. Okay, then the next screen, you're supposed to mention the project name here and the path to the project, and if you prefer any particular version of the SDK, the Flex SDK, I mean to say. So in this case, it's going to be 4.6.0, the latest. And all right, so the next screen for the project, the project wizard is the mobile settings screen. In fact, you can actually build Flex applications that can target more than just the Android platform. As you see here, you can target, for example, the BlackBerry operating system, or you can also target the iOS devices, iPhone and iPad. So in this case, we are going to just look at Android. Okay, so another important setting that you might want to specify is the application DPI. It's a dots per inch, makes the application look much more crisp when you put it onto a device. And of course, if you want the application to go full screen or you want it to be in windowed mode, you can specify with this checkbox here, and then you can specify, for example, how your application looks like. Is it based on views? Is it based on tabs? Or is it just, for example, a blank application with just one screen? So in this case, we are just going to take an application that has one screen. I mean, just to keep it simple. All right, so as I mentioned, you remember we were talking about application permissions when we discussed the initial part of this webinar. So in fact, we are at the same point. So even when you're building a Flex application, you must make sure that your application is explicitly specifying what permissions it needs to run successfully. As in this case, I want to have internet access, I want to have the ability to write to the external storage, which is the micro SD card in this case, and for example, I obviously need to have access to the camera. So these are the application permissions which my particular application is going to expect. All right, so moving on, okay, so I think it's time to look at the code itself, and I think we can look at also the demo on screen sharing before we jump into the source code. All right, so let's start up the phone again. so let's look at the application on screen sharing. Okay, so just give it a moment. All right, so we have the phone online. So just a moment. Okay, I think we have a crash. Let me try to restart. Okay, one thing is pretty obvious, and that is the, sorry. Okay. Okay, yeah, okay, sorry. I think we already have one instance of the DDMS running. So let me now try to start up the DDMS again. Sorry about the glitch. So just hang on for a moment. All right, so one thing that I would like to mention here, and that is if you want to practically build and deploy Flex applications onto an Android phone, you must make sure that you have a ARM V8. It's, I think, ARM V8 Cortex processor. So you'll need, you'll have to make sure that you at least have a V8 or a V7. So that's the one thing that you need to keep in mind. And please also keep in mind that you need to install, you'll have to download and install Adobe Air from Android market. So once you have installed Adobe Air, then you can actually run the application. All right. So there is the screen sharing, and thankfully it has started off right now. Okay. So now let's look at the application. All right. So you see the CameraDemo debug. Okay, so I'm going to click on that. So that is the Flex application that we have built, and what you see right now, I think we can rotate the screen. Okay, so I think yes. So this is in fact a live preview of what is being seen by the phone. Okay, so this is a live preview. All right. So the point is, this is not the default camera application. What you're looking at here is a Flex application. Okay, so from inside the Flex application, we are able to preview camera. Right. So now, if you observe, there is a toggle button. I'm sure at this resolution it's difficult to. Yeah. Okay. Sorry. All right. So there is a toggle button. So once I click on the toggle button, you are going to have a look at the presenter of this webinar. I apologize for that. All right. So once I click on the toggle button, there it is. That's me. Okay. So hello to all the viewers again. All right, so let's toggle again. So that's it. And once I click on the capture picture button, so this is going to get saved onto the SD card of the phone. I'm not sure if you have a SD card installed, but in any case, all right. So once you click on the capture camera button, sorry, the capture picture button. So yeah, that's it. So I think yeah, all right. So that's the Flex application. So now let's quickly go into the source code and have a look at it. All right, sorry. So we don't need Eclipse for this. We have to start Flex Builder. All right, so just give it a moment. This is a pretty heavyweight application. Okay, let me quickly go back, see if we have missed anything. No, I think this is fine. Okay, so quick look at how you actually can deploy a Flex application. Okay, so in this case, what we do is we specify something called as, okay, so you specify something called as a run configuration. Just give me a second here. All right, yeah. So as you can see here, this is a list of applications that we have built. But anyway, so the point is that you need to specify. When you actually deploy a Flex application, you need to specify what is called as a run configuration. Okay, so the run configuration offers you two options as usual. One is the emulator. As usual, there is an inbuilt emulator even for Flex Builder, and two, you can actually have a device connected the computer, and you can actually deploy it on a device. So the typical run configuration provides you with these two options. You can run on the emulator or you can run on a device. All right. So in this case, what we are going to try is we are going to pick on device. Okay. So once you pick on device, you can actually deploy this application onto a device that you might have already connected to the computer. So in this case, we already have a phone connected to the laptop here, so it is directly deployed onto the device, and which we have already seen. Okay, so yeah, okay, so I think yes. Okay, so we are through with the slideshow. Let's now just spend 2 minutes on the code here and quickly analyze it. All right, so this is the CameraDemo project that you see here, and it is structured this way. So there is the usual SRC folder which contains, in this case, obviously this is not, this is Flex, so it contains a file that is called as MXML. It has a MXML extension, so this is the place where you have all the code, okay? And then there is the Flex library itself, the runtime. All right, then there is the bin debug folder and the famous APK file which is actually deployed onto the device. All right, so quick look at the screen. So this is how it looks like. So if you remember, the screen, even though it is designed using drag and drop, always remember that in the back end there is an XML representation for the layout. Okay, so as you see here on the screen, we have a capture picture button here, and there is a toggle button which I use to toggle between the front and back cameras. And I think this, okay, it's not seen, but you have an invisible object here which actually renders the video for the camera from the camera. All right. Okay. So quick look at the source code, which we'll try to understand here. So yeah, as usual, two things that you'll have to understand. One is this code which I'm highlighting right now on my screen. This is the graphical code. Okay, so this is the XML code which I was talking about. So this is the MXML code which I was talking about, and this is in fact the layout, what you see here graphically. Okay, so this is the graphical part of the application, and then below we have something called as an FX script node. But if you observe inside this, the code which I'm highlighting right now, this is in fact action script code. So just like in the case of the Java projects, we saw that the XML was used to design the screen, and then Java was used as the programming language, or in the case of the native application, we also used C as the programming language. So in this case, the programming language is ActionScript. Okay, so pretty straightforward. So what we do is, first we try to initialize the settings for the camera, and that is this particular set of code that you look at. And yeah, so then there are two cameras. Remember, we assume that the device has two cameras. There is a front camera and there is a back camera. The front camera is represented as 0 and the back camera is represented as 1. So you can imagine that when I click on the toggle camera button, I simply call this particular switch cam method, and the camera gets switched between the front and the back cameras. And then there is a method here called as attach camera. So that that takes care of the attaching the camera to the live preview on the screen. All right, then once I click on the capture picture button, so then there is a function called as getPic, which I call, if you observe here, this is it. Okay, this is the button for which the label is capture picture. So you can imagine that this is the button which you saw there on the top right hand corner of the screen, and when that button is clicked, this is the event handler which takes care of the processing. So it's simply a method called as getPic. So let's now look at what getPic does. So the point is, it's just going to create what is called as a bitmap data object, and it simply draws, it renders whatever is the frame of video which is right now being previewed by the camera. So pretty straightforward. Then what we do is we call a method that's called as a write file, and we pass it the bitmap. Okay, so inside the write file method, what we do is we have a JPEG encoder class that is already inbuilt in Flex. So we take the JPEG encoder, we set it a compression rate of we set a quality rate of 100%, which means it is lossless. Then all we do is encode the bitmap data into simply a byte array, but in fact you can imagine that the byte array actually contains JPEG data, okay, in the JPEG format. All right, and after that what we do is we simply create a file stream object, and the file stream object is, you can imagine, these 3 lines of code actually do the writing to the SD card. So what happens in this case is we simply create a file stream. The snapshot.jpg is going to be inside inside the documents directory. You can actually browse this on the phone after you capture a screenshot. So you can imagine what the up the file in write mode, then you simply write the JPEG data into the file and you close the file. So it's as simple as that. All right. So I think that brings us to the end of the 3rd trial, and in fact that brings us also to the end of the webinar. So yes, so yeah, so I think we are through with that. So yes, so I think we are done. So thanks a lot, and I think I can actually take any questions from the audience at this point.
Questions are already there.
Okay, so just a moment. Right, let me check. Well, we have quite a lot of questions. I'm sorry about that. Well, actually, you can use any version of Eclipse that is pretty recent. So I would specify you can go with, for example, Eclipse Helios, but you could also use, for example, Eclipse Indigo. So I mean, there's no particular reason for having used Eclipse Indigo. Those, I mean, I think you I understand where you're coming from. So it's a checklist, right? So it is all I've recommended there is the most recent software. That's all. You can actually play around with it. You know, go back to older version